Hey, who's that?
So did Patrick.
Huh?
So did Patrick.
No, he's gone. He's gone. Okay.
Is he really gone?
He is, yeah.
Oh, is he coming back?
Yeah. Gone.
Why?
He says he doesn't like Grace
What?
or Amanda. So he left. Alright. I don't know why. I don't know. He just withdrew. Okay. Dimension of PV first. Did you try this? Okay, so PV. What's the formula for P? Pressure. Force over area. Yeah. But can anybody tell me what you get when you do volume divided by area? So remember, volume is like meter cubed and area is meter squared. So together, meter. So this is force multiply length. So the units will be, what's the unit for force? Newton. And length? Meters. Does Newton meter look familiar?
Yes.
What's Newton meter? Do you remember the formula work equals force multiplied distance? Yes. So that means joule is Newton meter. So this is equal to a joule. So the answer is units of joule. Next. What is the pressure on an airplane 10,000 feet high? 3 feet is about 1 meter. Okay. Can I go down? Yes. Right, so here is the ground. Here is the plane. Here's the plane. And this distance here will be 10,000 over 3 meters. And this is the sky. And you want the pressure. Yeah? Okay. So we'll call this distance here x. And we have this calculated from the previous lesson. What did we say it was? Like 6.7, was it? Yeah. Was it? I don't remember. I don't want to recalculate it, but we need to know what the total height is. We have this calculated from the last class. It was something like 6 or 7.5 maybe? 7,300. Yeah? So then the x would be, I should call this maybe big H. And I should call this maybe small h. So that would be 7,300 minus 10,000 over 3. so that is 3967 meters. So the pressure is rho GH, and the density of air is about 1.4, I think. If you want to use 1, that's fine, if you don't remember it, but I'll use 1.4 for air. No, I'll just be lazy and use 1. 1.2? Okay, I don't remember, I'll use 1. In the exam they would give you it anyways. G 9.81 and H is 3967. So this would be in kilo, 38.913 kilopascals. What was 1 atmosphere? 1 atmosphere was 101.35. Okay, 101.35. So if you wanted to, you could say that 0.384 atmospheres. So the pressure is quite low at this height. Yeah, 101.35, yeah. Is that okay?
It's always from the top to the...
Yeah, you told me this yesterday.
Yes.
You were right, yes.
But yesterday after class I forget.
Okay, well, do you remember now?
Yes.
Okay, good. Okay, can I look at the next one? Number 3.
Also, you finally can they give the H.
This here?
Yeah.
Well, what they might do, Andy, is part 1 of the question could be to calculate the H, which is what I did yesterday. Yeah. Yep. Why doesn't the law we did yesterday, the gas law, why does that not work for liquid? So you remember we had 4 assumptions? Yep, that's one problem. So number 1, there's a force between the water molecules. And also another reason, the density is not small. It's actually pretty big. It's about 1,000 kilograms per meter cubed. Yeah, so that's a couple of reasons. And the same for a solid. The biggest problem is there's a very strong force between particles.
What is the second one?
This one?
Something.
Not small.
The force between water molecules is high, right?
It is. There's a lot of friction forces they rub against each other. Yep. Okay. Hmm? You understand the product rule,
The chain rule.
but do you understand product
Yes.
and quotient?
Yes.
But chain?
No.
No.
Don't tell Joe.
I won't. It's our secret. Okay, number 4. Okay, so in number 4, what you have is you have a building. and this is 10 meters, and this is 10 meters, and then up the top, here it is, this is 10 meters, and this is 10 meters, and the distance here is 100 meters. So the pressure at the bottom is about 1 atmosphere. The pressure at the top, will it be more or will it be less? Yeah. The pressure at the top, you can get it by using the formula rho g h if you want.
H is 100
Yeah. No.
minus
The distance from the top,
0.
from the sky top. Yes.
What is
Huh?
what is
We said earlier was 7,300.
Did you remember it?
Huh?
Did you remember it?
No. But I don't think if you look, I don't think you need to use that number here. So for example, I want the difference in the pressure from which will be bigger, the bottom or the top? The bottom. So we'll call that P, we'll call this one, I don't know, P1 and P2. So the difference in the pressure will be P2 minus P1. So this distance here from the sky down, that's big H, isn't it? Can you see? And then this distance here, we'll call it small h. Does that make sense? So the first one will be rho g, big or small h? Big or small h? But no, big H. And then the second one is rho g, small h. But what you could do, you don't need to know what big H is, you just need to know the difference between big H and small h, which is what? 100, yes. So rho g 100, 9.81, 100. So the difference is 981 pascals. The question didn't ask for the pressure, it asked for the difference between the top and the bottom. Because of this, it means I don't need to know the big H. But you could know what it is, because here, this is 101.35 kilopascals, so the one up the top will be 101.35 minus 0.981. So this up the top would be 100.369 kilopascals. The difference is this much.
The pressure is from the sky to the bottom.
Yeah.
The ground.
Yeah. Yeah. And what I'm saying is, if you do the question this way, you don't need to know what the big H is. From the sky to the ground.
Can you show like one more time about big H?
Which part? This one?
And how to find the Earth from
Let's see. Okay, just before I do that, I just want to show you, for example, with number 2 again. So just have a quick look at number 2. Here's the sky. Here's the plane. And here's the ground. So this distance here we'll call small h, and this distance here we'll call big H. I'll call this pressure here P2 and this pressure here P1. So the difference in the pressure will be P2 minus P1. That would be rho G big H minus rho G small h. Is that okay? So that would be rho G big H minus small h. Then do you know this? You do. We'll call that x. The height. The altitude. So do you know this? You do. Yeah. So this will be rho G x. So in this example it'll be 9.81 and then 10,000 over 3. So that would be 9.81 times 10,000 divided by 3. Now that's the difference in the pressure is 32.7 kilopascals. So what's the pressure on the ground? 101.35. But this is the difference. So up here it should be 101 minus 101.35 minus the answer. So this will be 68.65. Now is that what I got last time? It is, isn't it? Or no?
No.
What did I get last time? I made a mistake somewhere then. Oh wait, did I use 1 last time or 1 point? What did I use last time? I know I used 1.
You use 1.
So then, where's my mistake? Maybe I typed it in wrong.
Huh?
Yes?
This question is question 2.
Yes. I'm doing 2 again. Wait. What did I get last time? 38.
How did you get the big H?
You told me it.
Yeah.
Is that right, this
Because
big?
I just read the question and don't get anything.
Is that right for the big H?
3.5.
Some mistake.
Maybe the total H, the big H is wrong from.
Maybe the big H is wrong from yesterday.
No, from the. Yeah.
Let's recalculate the big H to see. Maybe that's wrong. Alright, so we have our sky and we have our ground, and here is 101.35 kilopascals. So we'll call this height H, or big H maybe. So pressure is rho G H. Maybe the problem was yesterday I used 1.4, was it?
1.2.
Well then this is the problem why it's not the same. Yeah, so if I use 1, I get 101.35 times 1,000 equals 1 times 9.81 times H.
Wait, why
This is the problem.
So actually it's 1.2 or it's 1.
It doesn't.
It affects the answer.
It will affect the answer. The exam will tell you what to use. I'm just using the number from my memory, so I don't mind. 1 is easy to remember, but I know it's not 1. It's 1 point something. 1.2. Okay. It's there. Okay, thank you. If I use 1, which is what I was doing today, I'll get H instead is 10,331. So this is the reason for the difference between the two methods. It's because I'm not using the same value, because I don't know. You got this? 10,331? Yes?
Wait,
10331, yeah. So good news, if you use this number for H, you now get the same answer. Can I go back? So here, if I go back to up here, if I use instead 10,331, then this number changes to this number changes to 6998 instead, meters. So then this number changes as well, which means this number now is 68.6 kilopascals, and if I check it with the other way I did it, what? No, hang on, don't panic. Here it is here. 68.6. It's the same now. Okay. I should stick to one value for air density. I shouldn't keep changing it. Okay, is that okay, Andy? I know you were asking me about this. Yeah. Can I do the next one? Yes? What is the kinetic energy of air in a balloon 30 centimeters wide? Okay. 5. So you have your balloon. Radius is 0.30. So what's our formula from yesterday? I think we had PV equals, yeah, 3 over 2E, wasn't it? 3 over 2E, yes? So energy equals 2 over 3 PV. Well, you wrote it down yesterday, you tell me.
2 over 3?
PV equals 2 over 3.
Oh my goodness. Hang on.
Correct.
Is it?
Yeah.
Should I trust you?
Yeah.
I should trust you. Right, E,
V is
volume. Yeah.
P
Pressure. Okay, so the energy, 3 over 2, and the volume is pi r squared. Now, do we know the pressure? Well, we kind of do. If here is 1 atmosphere, the pressure on the inside must be 1 atmosphere.
Oh,
Yeah, if it's less, then what will happen to the balloon? It will shrink, yeah. And if it was more, it would explode, yeah. So to be balanced, it must be equal. So that's 101.35 times 10 to the 3. Right, so I get here 42.98, so kilojoules. So that's about 43 kilojoules. which is a lot. Mhm.
Think that would be helium, not,
Helium, yeah.
not air, normal air. Do you want
Yeah. Yeah. Okay, you got this?
No.
Okay. Yeah. Continue? Okay. A gas cylinder with radius 3 and length 10 is under a pressure of 3 atmospheres. A mechanical arm pushes down on the cylinder and thus reduces its length to 5 centimeters and increasing the pressure to 3. Okay. So what you have here is a cylinder. Its length 10 centimeters and then 3 centimeters. And there's some gas in here. And the pressure in the gas is quite high. It's 3 atmospheres. Then somebody pushes the arm down, the cylinder down. So now it's 5 centimeters. But this is still, of course, 3 centimeters. There's the gas still inside it. And now the pressure is 7 atmospheres instead. So there is some force that pushes down here.
used to be 10 centimeters?
Yes.
And then push it to 5?
Yes. So how much did it push it? It pushed it 5 centimeters. Yes, so first question is, do we understand what's happening in this story? Yeah? Now does this make sense that if you have the gas in the cylinder and the arm pushes down, then this arm, it must do some work because it's hard to push it. Yeah? What's the formula for work? Force multiplied by distance. And what's the distance the force pushed it? 0.05 multiplied by F. It moved, it pushed for 5 centimeters. But there's a problem if you do it this way. What's the problem? We don't know the F. But there is another way to do it. You can also say the work done is the change in the energy. So if this got more energy, it got more energy because the arm did work to it. So we think the energy here should be bigger than the energy here, and it got the extra energy from the arm. So we have energy 2 minus energy 1. What's the formula for energy? I think we said it's 2 over 3, no, 3 over 2, is it? 3 over 2 PV. 3 over 2 PV minus 3 over 2. Now, do you know the P's and the V's? You do. 3 over 2. Well, I'll just calculate it.
The 2 is the smaller one, right?
The 2 is the, sorry, this is E1 and this is E2. Ah, you know.
The formula.
You know this formula?
Mm-hmm.
Yeah. Alright, so P is firstly 7 and 3 atmospheres. Okay. And the radius is 3. Right, so here we get for the first part 3009 joules minus, and then for the second part oh wait, hang on, there might be, I'm sorry, oh no, that's wrong, sorry, let me fix that. I forgot my height is 10 centimeters.
The height is 5 centimeters.
No, I'm doing, oh, thank you, the height is 5 centimeters.
The P should change unit.
Change unit?
Oh,
What do you mean?
because the Pascal is KP.
Oh yeah, you should make it 10 to the 3. Yeah. Okay, and then we go from that to 3. Right, so this one is 129. .4 joules. Yes? I just put the numbers in, there's nothing special. So the last part here is what was the force?
21,
No, this is the work done. So if you go back to this formula, you can get 21.4 equals 0.05 F. So then F equals 428 newtons. Yeah. Good. Continue?
No.
Just waiting for Amanda? What are you doing in chemistry?
Organic
yeah,
and
the
family.
alkenes, the functional group.
Yeah.
Boring.
Amazing.
Is it?
Yes.
No.
And
Is it?
because we translate to Chinese, the letter is too complex.
I
Okay.
didn't.
Every letter is just like the same.
And what are you doing in maths? Chain rule? That was the last lesson?
Nearly there.
You're
Killing me.
killing you.
After yesterday's math class, my brain froze up.
Yeah.
Don't worry, it's not so bad.
And I think